Welcome back to my math YouTube channel. Today I'm here to talk about the inverse trig functions. Guys, we have already figured out, or we already know how to find the trig functions for different angles. Now we want to talk about the inverse process. Guys, this is not only important for evaluating the inverse trig functions, but this is something which is very important when we try to, or one tries to solve trig equations. So guys, this is the concept that we need to know and learn before we start actually solving trig equations. That is the reason why I want to talk about this, and even in your textbooks this comes before solving trig equations. So guys, one has to understand this. Here I'm going to try to illustrate this with some simple examples. Guys, there's still things that you have to keep in mind, or you have to remember, and I mean one has to remember those things if one is going to use the idea of an inverse trig function, and if one is going to actually evaluate these inverse trig functions. So guys, so far we already know how to find the value for the sine, cosine, or any of the trig functions. So for example, guys, we already know, like if I have to find the sine of, let's say, pi over 3, we already know how to do that. Or let's say cosine of 2 pi, or let's say tangent of pi over 4, and so on and so forth. So far guys, this is what we have been we already know how to do that. Now there are different ways of doing it. Guys, let me just write like these different ways, and let us just recall what are the different ways of actually evaluating this. One of them is you can use a calculator, right? Calculator for this. Guys, the second way is the unit circle, and I always have a handy unit circle with me. Guys, if you do not have a unit circle handy with you, then you can still go back to your textbooks. I'm sure you have a textbook for this course, so you can, I mean, most of the textbooks have a unit circle. You can use that. You can use the textbook for the unit circle, or I'm sure you may have a copy of the unit circle with you as well. So the second one is using the unit circle. And guys, if you're not allowed to use any of those for the test, or I mean, if you're not allowed these two things, then the other way is you have to just memorize a lot of stuff. Guys, I'm not a big fan of memorizing a lot of information, but there are a few basic things and basic facts or basic laws that one has to memorize, and then the rest of the stuff kind of builds upon that. And then guys, the fourth one is like you have to know the special triangles. Well, with special triangles, mostly there's two of those, there's 30, 60, 90 triangle, and then there's 45, 45, 90 triangle. But then those two triangles are not going to cover all the different angles, so one has to know more than that. But guys, these are essentially four things that we have been using in order to actually evaluate the value for these trig functions. So guys, so far this is something we have been doing, and we can look at the unit circle or use any of those things to finally write the values for this. Guys, I'm not going to write the values here. I just wanted to like illustrate, I'm trying to illustrate the idea of the inverse function, but I wanted to start with things that you already know, or the things that we already have been working on. Now, guys, in the inverse trig function, in this section, we want to talk about something which is called like an inverse process. So what is this inverse process that we are talking about? So before actually formally writing down the formal notation for the inverse and how does it work, guys, first of all, I want to basically like write in words what does this inverse process mean. So guys, this inverse process in context to this basically means, now from here we're doing the inverse. So for example, again, I'll illustrate this with an example. For example, we know sine of let's say pi over 4 is radical 2 over 2. Okay, that is something we already know, and we can look at the unit circle or use any of those technique, calculator or whatever. So guys, this is something we already know. Now the inverse process of this, that is what we want to talk about now. The idea of the inverse process is basically something like this. Now we want to find the value of the angle, so that so I'm specifying this to this particular example, so that the sine of that angle gives me radical 2 over 2. So if I have to write this as a mathematical equation, and guys, keep in mind, we're talking about the inverse process. So basically we are trying to find this theta for which the sine of theta is radical 2 over 2. Guys, this is what we are actually looking at. We are trying to find this theta. That is basically the inverse process of an original sine function. Then same for cosine, tangent. I mean, this is the inverse process of a trig function. Guys, this inverse process can be formally written as, there's two ways of writing it. One is called the arc sine, So this is for sine function. Similarly, if I have cosine, then I'm going to say arc cosine and arc tan and so on and so forth. Guys, this is one way of writing the inverse. The other way, which you will find mostly in the textbooks, is something like this: sine inverse of x. Or for cosine, it would be cosine inverse of x, or tangent inverse of x. Guys, you have to keep one thing in mind before you start actually doing anything with these types of functions, these inverse functions. And that is the fact that the sine inverse does not, so I'm going to get rid of some of this so that we can talk about now. So keep in mind, guys, this sine inverse x is not 1 over sine x. That is something, sometimes students make those mistakes. So I want to clarify that right here. Guys, we already know 1 over sine x is the cosecant, that is the reciprocal of the sine, but that is not the inverse. This is not the inverse, okay? So keep that in mind. That's true for all of these. That is something that I want you to keep in mind. But then, guys, the most important thing that we have to figure out or understand in the inverse section, inverse trig functions or inverse processes, that now we are trying to find, here we were trying to find the value of the trig function, whether it's sine, cosine, or tangent, right? Now we want to do the inverse, okay? The inverse means we want to now find the value for the angle for which the sine or cosine, or for that matter, any trig function has a particular value, okay? That's exactly what we are trying to do in the inverse trig function section. So guys, I want to talk about now how can we actually evaluate the inverse of trig function. So let us start with a simple example again. So guys, one of the examples, simplest example that I'm going to start here is, let us say we want to evaluate the sine inverse. Let's say I want to evaluate the sine inverse of, let's say I want to 1 over 1/2. Okay. So guys, to figure out the sine inverse of this, what does that first basically mean? Let us try to understand that this inverse. So this means for what angle theta, let's say for what angle theta, the sine of theta equals to 1/2. That is basically what we are trying to evaluate. In order to do that, again guys, yes, you can use a calculator, or you can use a unit circle. I would suggest first start using the unit circle for that. So I'm looking at the unit circle and I'm basically looking at this expression and I'm asking myself, and that is what exactly we should all ask ourselves, what does this mean? So first of all, we have to understand what does this mean, and now we understand it means we have to evaluate, we have to find that particular theta for which this value is 1/2. So guys, I'm trying to now look at from this, and this is just an equivalent equation written out in a slightly different way. What is the value of theta for which the sine theta is 1/2? Now I'm looking at my unit circle, and from my unit circle I can see that the value for theta is 30 degrees, or which is same as pi over 6 radians. Okay. But then guys, I'm not going to stop right there. Then I'm going to, that's in the first quadrant. But when I go in the second quadrant, again I see that for sine of 150 degrees, it's again the sine of 150 degrees is also 1/2. Then I look in the third quadrant, I don't see anything, which gives me 1/2. Again in the fourth quadrant I have negative 1/2. Same thing in the third quadrant, and we already know that sine is positive in the first and the second quadrant. So guys, I get these two values, and then from this I may conclude that hey, this has two values, maybe 30 degrees and then also 150 degrees. Now guys, this is something that we have to be very careful with, that when you evaluate the sine inverse or cosine inverse or inverse of any trig function, we have to watch out for the right domain and the correct range for these functions. So guys, in this video, I'm going to basically kind of stop right here. And all I'm going to say here is that for sine inverse of 1/2, the only correct value is 30 degrees and 150 is an extraneous solution. That is not the correct answer. Only 30 degrees is the correct value for sine inverse of 1/2. Guys, the reason for that is something that I'm going to explain in my next video, because I don't want to make this video like a big huge video. In my next video guys, we are going to talk about, briefly we're going to talk about the graphs, the idea of the function, the idea of a domain and range of these trig functions. Especially we'll talk about the sine and then cosine and tangent, and we will write the domain, range for all of these three functions, guys, that is something that one has to kind of remember. It is not like memorizing something. It is kind of it's kind of easy to remember those things once you have been working with these functions. You know how the graphs look like, and from the graphs you can easily remember the domains and the range. And then, guys, with some conceptual things that come handy from algebra and pre-calc, we can understand the restrictions for sine as well as for the sine inverse, or for the trig functions as well as their inverses. Okay, guys, once we understand that, then we'll be able to justify why sine inverse 1/2 is only 30 degrees and not 150. Okay, guys, till then, take care. I will see you in the next video with